On the triangle problems, IU Final likes to use alpha, beta, and gamma for their A, B, and C. So if we ask you to find angle alpha, that's the same thing as angle A. If we ask you to find angle alpha, that's the same thing as angle C. So there's no confusion on there. I strongly suggest in all these solving the triangle problems that you draw yourself a picture first there. So I could put A, B, or C, or I could put alpha, beta, gamma, doesn't matter. And then I know that that B, this angle right here is 53 degrees. And then the little a is opposite angle alpha. So this will be 11. And then the little b is opposite angle beta. So that'll be 18. And then remember when you're solving the triangles, when you're trying to decide whether I'm going to use a law of sines or law of cosines, if you have this friendship completed, when you know the angle with its opposite side, that's when you can use the law of sine. So I'm going to make that sine of 53 over 18 equals the sine of alpha over the 11. And then I can use this to figure out what that angle alpha is. So I'm going to cross multiply. And remember the little shortcut that we learned before. You can go sine of alpha when you're trying to solve for this item. Was the shortcut is you multiply the completed diagonal together. So you can make that 11 sine of 53. And then you divide it by the one that you have left over, which is 18. And then you have sine of alpha is equal to that number right there. Now remember, when you don't know that actual angle, that's when you need to, so I guess I didn't need to do that part there, but when you don't know that angle, what you're going to do to find the angle is hit the inverse sine button in the calculator. So you're going to do the inverse sine of that right there. And so when I'm going to do that in the calculator, we'll show you that. Make sure your calculator is in degree mode, and then you hit second sine, and then you just type in 11 sine of 53. Close that angle, divided by 18, close that, that's going to give us 29.21. And everything's to the nearest hundredth, so we're going to go 29.21 for angle alpha. So we got that one. And then once you have that one, then we're going to need to just figure out the gamma, and we're going to need to figure out that little c right there. Now, notice that you have two of the angles already, right? And so if you now know that this angle is 29.21, you can subtract from 180. I can go 180 minus the 53 minus the 29.21. So you subtract the two angles that you already know, you're going to get that negative 97.79 degrees. So the angle gamma, which is angle C, is 97.79 degrees. And then so once you figure out that this is 97.79, then you can use that to figure out that little c. We can do the law of sines one more time. Now what I'm going to do is stick with the 53 and the 18 because those were given to me. Those are exact numbers. The 29.21 is a rounded answer, so I'd rather not use that if I can avoid it. So I'm going to do the law of sines one more time. Sine of 53 over 18. This time we're going to go sine of the gamma over that little c. And then you cross multiply. Actually, that gamma is the 97.79. So you could throw that in there for that angle. And then when I want to solve for that little c, you multiply the completed diagonal together. And then you divide it by the one that you have left over. And so we'll plug that into our calculator. So I'm going to go 18 sine of 97.79. Close that angle, and I'm going to hit divide by the sine of 53. And it's going to give us 22.33 for the little c. So we now have everything that we need. And so what we'll do is we'll give you a problem, and then we'll ask you to find the certain things there. And then if we just ask for a particular thing or all three things, then you just make sure you look for what you're looking for and write that down where the answers are at. All right, now letter B is you're given all three sides of a triangle. So we're going to do this one from scratch, and I'll just talk you through a couple of the other ones here. So again, draw yourself a triangle. This time I'm just going to use A, B, and C. And then the little a is 7, little b is 6, little c is going to be 9. Now, when you don't have any of the angles, you can't use the law of sines because you don't have the angle with the opposite side. You don't have that match, you don't have that friendship completed, which means you need to use the law of cosines. If you start with the law of cosines here, then you need to kind of keep working with the law of cosines the whole way through. So I'm going to use the law of cosines to get two angles. I'm going to do it twice to get two different angles, and then we'll subtract from 180 to get that third one right there. So with the weird cases out there, you shouldn't have to worry about those too much, but I'm always in the habit of starting with that largest side, okay? So I'm gonna go 9 squared equals, remember how the law of cosines works. When you stick with this side, that means you're working with these other two sides here with that opposite angle right there. So I'm gonna do the 7 squared plus 6 squared minus 2 times the 7 times the 6 times the cosine of that angle C. And what we showed you how to do before, we said this is going to be 81. You could plug these into the calculator. This would be 49 plus 36, which you could do on your own. That'd be 85. And then if you go 2 times 7 times 6, this will give you 84 times the cosine of C. You can't subtract those. This is like 85 minus 84x, okay? So you have to move this 85 over there to that side. So I'm gonna subtract the 85 over. So 81 minus 85 is gonna be -4, right? And then this is like -84 times that. So you're gonna divide both sides by that -84. So we'll get cosine of angle C, and then -84 divided by, -4 divided by -84. You could just leave it like that, but I just know it's going to be reduced to positive 1 over 21. The calculator do that for you. And if you don't know that angle, you're going to do the inverse cosine of that 1 over 21. And so when you do the inverse cosine of that 1 over 21, you know how to do that in the calculator. You're going to get this 87.27 degrees. And then what we'll ask you for, it might not say angle C, it might tell us to find angle gamma, and then that's what we're looking for right there. And I'm gonna need to do this. So if I just know that 87.27, I'm gonna need to do this one more time to get that second angle here, okay? So I'm gonna go to the next largest side. It doesn't really matter at this point once you got that largest angle there, but you're gonna go to that 7 squared. I'm gonna do the law of cosines again. So I'll go 7 squared equals, this time I'm working with these two as my opposite sides, and that's my opposite angle. So I'm gonna go 9 squared plus 6 squared minus 2 times 9 times 6 times the cosine of that angle A. And then you're going to move the 9 squared over and the 6 squared over. And then let's show you another way you could do that is kind of plug that all into the calculator. So if you leave it all in there all at once, remember what we did before, you can leave that as 7 squared, and then you're going to need to subtract the 9 squared minus the 6 squared. All right, and so I'm going to subtract it over. So I'm going to go 7 squared minus 9 squared minus 6 squared all over, and then you're going to divide both sides by that -2 times 9 times 6 right there. So when you move those over, what you're left with is this stuff. This is all multiplied times that cosine of A. And so when you want to move this over, and you're going to divide both sides by that. And so all I'm showing you here is another way that you could do this when you're leaving it all in the calculator, or if you like this method here where you do a little bit of numbers at a time and then leave that in there, then that's perfectly fine there. I just want to try and review that with you. But then what you're going to do to find your cosine A, you're going to need to do cosine inverse of all of that stuff, right? So let me clear that. So I'm going to do cosine inverse, and I'm going to plug all that in there. So I'm going to go 7 squared minus 9 squared minus 6 squared. All right, now that's just the top part. I should put that in parentheses. So I'm going to go back over here. There's an INS button probably somewhere on your calculator. If you hit second INS, and it'll insert a parentheses right there. So there's my numerator. I'm going to close that parentheses. Then we're going to divide it. I'm going to put the denominator in the parentheses. I'm going to go -2 times 9 times 6. Close that parentheses right there. And I can close my whole entire cosine inverse, which is going to give us, this is going to be that angle A, or which is the same thing as angle alpha, is 50.98 degrees. So we got that angle right there. I got that angle right there. And the only thing we're missing is angle beta. So remember angle beta, you're going to subtract those two from 180. So we're going to go 180 minus the 87.27 minus the 50.98. And that's going to give us 41.75 degrees. And we have all three of the angles, and we already had all three of the sides. So again, that's alpha, that's beta, that's gamma. So when you see those, we know what it is what we're doing. All right, I just ask whichever method you do, whether you like to get the numbers in there and solve it that way, or whether you leave it all in the calculator, be consistent with that when you're doing your practice, and I think you'll be much happier with that. Now, the last two, I'm just going to talk you through, okay? As you're working out letter D, there's all my work, there's all the answers. Letter D, you knew one of the angles, but you didn't know the opposite side right away. We didn't know that 17.52, so I couldn't use the law of cosines. I'm sorry, I couldn't use the law of sines on this one. I had to go straight to the law of cosines. So when you did that, I found this opposite side first, right? Because I knew that side and that opposite angle. So then I went straight to, hey, c squared equals the 17 squared plus the 12 squared minus 2 times the 17 times the 12 times the cosine of that 72 degrees. And then remember how you find this, you just hit your square root button first and you type all of that in your calculator exactly the way you see it, and it's going to give you that C is 17.52. All right, now usually I like to not use those rounded answers, but I'm stuck with using that on this problem. So then I use another law of cosines with this side, and this is the opposite angle like I just did on letter B. And then you kind of see my work there. There's a bunch more decimals there. So if you're rounding in the intermediate steps, I usually like to leave everything in the calculator and don't round until the very end. So practice, make sure you can get those answers. If you are doing the intermediate numbers in there and you're rounding, you got to round to a bunch of numbers after the decimal. That way, when you round your final answer to the nearest hundredth, it's not going to be off, or it's going to be accurate there. And then once you find that angle, you already know the 72, so then subtract from the 180 to get the other one right there. All right, now what I want to mention on letter C. Letter C is an easy law of sine problems, except there's a special case that's happening here that we haven't done a lot of, and so we need to just mention this, okay? So I give you those three items. So I drew my picture and I got those in there, and it looked like it was just going to be like letter A and do an easy law of sine problem, right? So I did sine of 71 over 8 equals sine of B over 21. Now when I did this, all right, look what happens when you don't know that angle. Remember what you're supposed to do. You're supposed to do sine inverse, and then you're going to do the sine inverse of that. Well, look what happens when I go 21 sine of 71 and I divide that by the 8. I get an error. Okay, so I get an error when I get that. So let me go back to that again in case you missed it there. So I did sine inverse of that 21 sine of 71, right? And then I divided it by the 18, divided by the 8. And see, it gives you an error. Now, when you get an error, you may have just entered it into the calculator wrong, okay? So I'll go back and I'll double check that. But here's what's a possibility here. What I then do if I get an error a second time is I'll go ahead and I'll just type this part into my answer. When I type this part into the calculator, it was equal to 2.48. And so whenever you have sine of A, sine of B, sine of C equals a number that's bigger than 1 or smaller than -1, you're going to get no solution for that. Because remember your sine graph just forever, and your cosine graph as well, it just forever fluctuates in between 1 and a -1. So if I get a problem where I got sine of A is equal to 2.48, that sine graph is 2.48 is up here. That sine graph doesn't go up there. You're talking your parent sine graph. There's no change in amplitude, nothing like that. So you got that whenever you got your sine, if it's bigger than 1 or smaller than -1, you're going to get a no solution for that. And the calculator will give you an error for that. So if you see that, that is a possibility for the final exam. So I want you to just kind of have that fresh in your head. Just double check it though. Make sure you get an answer bigger than 1. Like when I did this one here, this one on letter A, that was only 0.48, and so I was able to get a number for that because your sine is equal to 0.4 at some point in time right there.